Welcome back to my channel. Thanks for tuning in. I hope you're having a great day. In this video, we're going to talk about how to find the greatest common factor. All right, so what is the greatest common factor? So first, in order to understand the greatest common factor, you have to understand what a factor is. A factor is taking a number and writing it as the product of two or more numbers. So you have to have multiple numbers or terms or expressions to be able to find the greatest common factor. So you will find the factors of each factor of each term or each expression, each number, whatever it is you're looking at. You'll find the factors of each, and then you'll find the biggest one that they have in common. So for example, if you wanted to find the GCF, and GCF is short for greatest common factor, of say 30 and 45. What is the GCF for 30 and 45? So then there are really two ways you can do this. You can list all the factors of 30. So I could say things that multiply to give me 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Those are all the factors of 30. And then what are things that multiply to give me 45? 1 and 45, and 2 doesn't go in there. 3 and 15, and then the next number would be 5 and 9. Those are all the factors of 45. So look at these two and figure out which one do they have in common. That's the biggest. So they have 3 in common, they have 5 in common, they also have 15 in common. So the one that is the biggest is 15. So the GCF of 30 and 45 would be 15. All right, that's one way you can do it. Now, sometimes this gets pretty long depending on how big the numbers are. So there's another way you can do it, which is to take each number and break it down into its prime factorization. So what does that mean? You want to take each number and break it down to it's the product of all of its prime numbers. So for example, 30, just start with two multiples you know. We know that 30 is 3 times 10. Well, 3 is a prime number, so you would leave 3 alone. 10 is 2 times 5. 2 is prime, 5 is prime, so you will stop there. So 30 is equal to, and I'm going to write them in order, 2 times 3 times 5. And then 45, if you break that down, that's 5 times 9. You can start with any factors you know of 45. Well, 5 times 9 is 45. 5 is prime, so I will leave that alone. And then 9 is 3 times 3, and 3 is prime. So your prime factorization for 45 will be 3 times 3 times 5. Now look at these two and see what they have in common. They have the 3 in common, and they also have the 5 in common. So that means your GCF would be 3 times 5, which is 15. So that's another way you can find the GCF. And this is the most common way that is used because, again, if your numbers are really large, it could take you a long time to write all the factors out. Okay, let's try an example. So in this first example, we want to find the GCF of 72, 120, and 432. So again, there are two different ways you can do it. You can list all the factors out, or you can do the prime factorization tree or list it out as this prime factorization. So starting with 72, I'm going to use the second way because these numbers are larger. I don't want to be listing all the factors of 72 or 432. I don't want to be listing all those factors. So I'm going to start with 72, and 72 I know is 8 times 9. And 8 is not prime. That can be broken down into 2 times 4. 2 is prime, so I will leave that alone. 4 is 2 times 2. So both of those are prime. I will leave those alone. So once you get down to the prime numbers, you stop. 9 is 3 times 3, and those are prime. So just in case you don't remember what it means to be prime, prime means that there are no other factors of that number besides itself and 1. So no, there are no ways you can multiply to get 2 besides 1 and 2, 1 times 2. So that's prime. 2 is prime, 3 is prime, 5 is prime, 7 is prime, then 11. Alrighty. So 72 would be 2 times 2 times 2 times 3 times 3. So that's his prime factorization. You may also see this written as 2 to the third times 3 to the second. You can see it written in those two different ways. Alrighty. And then 120 is 12 times 10. So then 120 is 12 times 10. 12 is 3 times 4. 3 is prime, so I will stop there. 4 is 2 times 2, and both of those are prime, so stop there. 10 is 2 times 5, and 2 and 5 are both prime. So 120 would be 2 to the third. There's 3 2's times 3 times 5. So this is the prime factorization of 120. And then 432, if I break that up, that's 2 times 216. 2 is prime. 216 is 2 times 108. 2 is prime. 108 is 2 times 54. 2 is prime. 54 is 9 times 6. 9 is 3 times 3. Both of those are prime. And 6 is 3 times 2. So 432 is equal to, you have 1, 2, 3, 4 2's. So I'll write it up here. That's 2 to the 4th times 3 to the 3rd. So we got 1, 2, 3, 4 2's and 3 3's. So if I write this one up here, this was 2 to the 3rd times 3 times 5, and 72 was 2 to the 3rd times 3 to the 2nd. So now you want to look at each of these factorizations and see what they have in common. So for the 2's, this one had 3 2's, this one had 3 2's, this one had 4 2's. So they have 3 2's in common. So your GCF would have 3 2's in it. And then if you look at the 3's, this one had 2 3's, 1 3, and 3 3's. So they all have 1 3 in common. So you'll take basically the lowest exponent on the number. So for 2, the lowest exponent was 3. And then they all have a 3, and the lowest exponent on the 3 is 1. So your GCF will be 2 to the 3rd, which is 8. That's 2 times 2 is 4, times another 2 is 8, times 3, which is 24. So your GCF for these three numbers will be 24. That's your greatest common factor. So that's how you would do that. In this example 2, we want to find the GCF of 21m to the 7th, 18m to the 6th, 45m to the 8th, and 24m to the 5th. So now what's different from this one and the last one? This one actually has variables in it, but don't let the variables throw you off. You do it the same way. You want to break each number down. So for 21m to the 7th, break 21 down. That's 3 times 7. Well, 3 and 7 are both prime. So this would be 3 times 7 times m to the 7th. All right. 18m to the 6th. Well, 18 is 3 times 6. 3 is prime. 6 is 3 times 2. 3 and 2 are prime. So this would be, you have 1 2 and you have 2 3. So 3 to the 2nd and you have m to the 6th. So now 45m to the 8th. 45 is 9 times 5. 5 is prime, so we will leave that alone. And 9 is 3 times 3. Those are both prime. That's a 3 and a 3. And so this ends up being 3 to the 2nd times 5 times m to the 8th. It's 3 to the 2nd because we have 2 3's. And then the last one, 24m to the 5th. 24 is 6 times 4. 6 is 3 times 2. Those are both prime. And 4 is 2 times 2. So 2, that's 2 to the 3rd power, and that's 3. And then m to the 5th. So you have 3 2's, and then you have a 3 and m to the 5th. So we've broken all of these down into our prime factorization. So we want to look and see what they all have in common. So if we start with the 2's, they all don't have 2's. So 2 would not be something they have in common. If you look at the 3's, this one has 3 to the 1st, 3 to the 2nd, 3 to the 2nd, and 3 to the 1st. So the smallest exponent on the 3 is 1. So this would be 3 to the 1st, which is just 3, but I'll show you 3 to the 1st just so you can know I'm taking the smallest exponent on the 3. Then if you look at 5's, they all don't have a 5 in them, so 5 would not be a common factor. And if you look at 7, they all don't have a 7 in them, so that's not a common factor. But if you look at m, they all have an m in them, so you'll take m with the smallest exponent. The smallest exponent, 7, 6, 8, 5, is 5, so it'll be m to the 5th. So your GCF will be 3m to the 5th power. So that's how you would go through and find the GCF for this problem. Okay, this time we're going to look at an example that actually wants us to factor out the GCF of a polynomial. In this particular case, a binomial, because it has 2 terms. And so what we want to do is, if we want to factor out the GCF, then what we have to do is find the GCF of each term. So the 5y squared and the 10y. So 5y squared. 5 is already a prime number, so it can't be broken down any further. So the prime factorization of 5y squared is just 5y squared. However, 10y can be broken down. That's 2 times 5. And 2 and 5 are both prime, so you will stop there. This is 2 times 5 times y. So when you're trying to take the GCF of both of these terms, you look at the numbers and see what they have in common. They have a 5 in common. And then you look at the variables. This one has 2 y's. This one has 1 y. The smallest exponent on the y is 1. So your GCF will be 5y. So again, remember, you're taking the smallest exponent on the terms they have in common. So they have a 5 in common. The exponent is 1. Smallest exponent is 1. They have a y in common. The smallest exponent is 1. So I want to factor out 5y. So when I factor out 5y, I need to write what's left in parentheses. Okay? So how do I figure out what's left? So to figure out what's left, essentially what I do is divide out a 5y from each of these terms. So if I divide this by 5y, the 5's cancel, and y squared divided by y, I use the quotient rule and subtract the exponents. 2 minus 1 is 1. So I get y to the first power. So I'm left with y to the first power, which is just y. If I divide this one by 5y, 10 divided by 5 is 2. So I still have that plus sign. And then the y's cancel. So I'm left with y plus 2 inside the parentheses once I pull out a 5y. So this would be my answer. And if I wanted to go check it, just multiply the 5y back in and see if you get what you started with. 5y times y is 5y squared, and 5y times 2 is 10. So when I distribute this back in, I get what I started with. That's how I know that my factoring is done correctly. But this will be your final solution. This next example is really similar to the last one, except it's written differently. It doesn't tell us to factor out the GCF, but it tells us to write this polynomial, which is a trinomial because it has 3 terms. It tells us to write this in factored form. So basically what we want to do is factor. And the first step in factoring is to factor out the GCF. So that means I need to look at each of these terms, negative 8x to the 4th, 16x to the 3rd, and negative 4x squared. And I need to figure out what is the GCF of each of these terms. So 8 is negative 2 times 4. 2 is prime. 4 is 2 times 2. So this ends up being negative 2 to the 3rd times x to the 4th. That's what this one breaks down into. All right, 16 is 2 times 8. 8 is 2 times 4, and then 4 is 2 times 2. So you end up with 4 2's. So this ends up being 2 to the 4th times x to the 3rd. And then 4, or negative 4, is negative 2 times 2. So this ends up being negative 2 to the 2nd times x to the 2nd. So this is how each of these break down. What do they all have in common? They all have a 2 in common. They all have an x in common. Well, how many 2's do they have in common? So you want to look for the smallest exponent, which is 2. So your GCF would be 2 to the 2nd, and then they all have an x in common. Take the smallest exponent on the x, and the smallest exponent on the x is x squared. So your GCF would be 4x squared. Now, anytime your first term, so even though your GCF is 4x squared, anytime your first term is negative, you're going to want to factor out the negative of that GCF, because you always want your, it's still correct if you don't factor out the negative, but the standard rule is to factor out the negative because you typically want that first term to be positive. So instead of factoring out just the 4x squared, we're going to factor out a negative 4x squared. And so we're going to write what's left inside the parentheses to figure out what we get left. To figure out what we have left inside the parentheses. So you're going to take negative 8x to the 4th and divide it by negative 4x squared. So you're taking each of these terms and dividing it by negative 4x squared because that's what you're pulling out. Negative 8 divided by negative 4 is a positive 2. X to the 4th divided by x squared. If you use the quotient rule, you will subtract the exponents. That leaves us with the x squared. So now take 16x to the third and divide that by negative 4x squared. 16 divided by negative 4 is a negative 4. And divide x to the third by x squared. You will subtract the exponents. That will leave you with x. And then take negative 4x squared and divide that by negative 4x squared. If you divide those, since the numerator and denominator is the same, you end up with a positive 1. So that'll be plus 1 on the inside. So this would be your final solution. We found the GCF, which was 4x squared. Because this first term was negative, we pulled out a negative 4x squared. And if you take out a negative 4x squared, you're left with 2x squared minus 4x plus 1. How did we figure out what we're left with? We took each of these terms and divided it by what we were factoring out. And so that's how you would write that in factored form. This is how you would factor out the GCF. This is the first step of factoring. We're going to continue to learn more about factoring in the next videos. If you have any questions whatsoever, you can always put them in the comments. If you haven't already, make sure you subscribe to the channel. And hit that bell so you'll get notifications every time I drop a new video. Thanks for showing love. Thanks for tuning in. I will see you in the next video.